We welcome you to the expert video second sender LED. SICK offers diffuse proximity background suppression sensor with a second sender LED. Today we'd like to explain why we offer sensors with this feature.
The SICK background suppression sensors of the product families H18, W4S, W4F, W9 and W12 are equipped with the second sender LED.
Somehow, a diffuse reflective proximity sensor with background suppression is a distance measurement device. When a diffuse background suppression sensor is set or taught, a distance and not a sensitivity is set.
Here you can see that we adjust the sensor to a certain distance, exactly to the white cardboard. In this case, we thought a WTB12 by pressing the Teach In button. The expectation is now that the sensor detects the cardboard up to this distance and won't detect it behind. And of course, that's exactly what the sensor does.
Actually, that's the theory. There is always a tolerance range around the set sensing distance. Not every object is detected up to the taught sensing range, and you can probably imagine that not every object is ignored behind the set sensing range. Backgrounds with glossy surfaces, for example shiny machine parts, robot arms which are passing the sender light beam, and backgrounds with reflective surfaces such as safety vest can temper the sensor and can trigger faulty switching. The sensor detects an object even though none is in the set sensing range. This is a side effect of the working principle of triangulation, which is the most used principle. First, let's take a look what triangulation is all about.
The sender light, which is reflected by the object, is projected from the receiver lens onto a multi-pixel element. Where the light is projected onto the element depends on the distance of the object. If the object is further away, the light is positioned in the lower area of the element. If the object is close to the sensor, it is positioned in the upper area.
Yes, it is a simple and reliable way to measure the distance to an object. At the beginning of the video I mentioned that certain backgrounds can simulate an object in the thought sensing range. How can this happen?
In the real world, optical effects of the sensor design, as well as dust and scratches on the front lens, expand the light beam. The result is that there is a weak light cone around the visible core light beam. We call this the halo light. There's a chance that shiny objects or retroreflective objects in the background reflect the halo light back to the sensor. The light path back to the receiver passes the sensing range. To the sensor, it looks as if the light is coming from the sensing range. Of course, then the sensor activates the output, even though there is no object in the beam.
Now we understand why the sensor shows faulty switching based on a reflection of the halo light from a shiny object in the background. At this point, the second sender LED comes into play.
The second sender LED illuminates the field of view of the sensor with a weak, almost not visible light. Actually, the reflection of shiny and retroreflective surfaces only can be detected by the sensor. Because the main sender light and the light from the second sender LED are pulsed alternately, one after the other, the sensor has two signals for evaluation available. With this two information, the sensor can now calculate if the reflected main light comes from a real object or is just an unwanted reflection from a shiny background.
This is smart, isn't it? Sometimes small and simple features have a great outcome. So, background suppression sensors with the second sender LED offers a trouble-free, uninterruptible object detection with a high level of reliability in machines and production plants.